Here's pre-calc. This is problem number 7-132, and it wants you to write this as sum of two fractions with linear denominators by using partial fraction decomposition. So the sum of two fractions. So that means a fraction plus another fraction with linear denominators. So linear denominators would be like, they're not squared, they're just like x minus 3 or x minus 5. So let me remind you, because maybe you haven't done this for a while. We are trying to write it as the sum of two fractions with linear denominators. So we know that if we started out with something over x minus 3 plus something over x minus 5, we know we could add these up by getting a common denominator. Like we could multiply this first fraction by x minus 5, like a giant 1. On top and bottom, we can multiply the second one by x minus 3 over x minus 3, and we could somehow turn this into that. But we don't know what these two numerators would be that would actually turn out as 5x minus 19. So this is just a process that you're going to use. You're going to find this very useful if you go into any higher math, to be able to pull these apart, to pull this into two fractions with linear denominators. So what we do is we write the original thing, the original numerator, and then we're going to set it equal to, like this original fraction is going to be equal to our sum of two fractions with the linear denominators. And then we're going to do algebra to try to figure out what has to be on top of the first fraction, like in the numerator, and what has to be the numerator of the second fraction in order for these two to be equal. So we're going to clear some denominators. Just start out by, we're not going to clear them all the way out, but we're going to, we're going to clear them all the way out. So we're going to divide or multiply both sides by x minus 3 times x minus 5. So these cancel all the way out, and then when I multiply x minus 3 times x minus 5 against this fraction, the x minus 3's cancel out, but not the x minus 5. So I'll have a times x minus 5. And then when I multiply x minus 3 times x minus 5 with the second fraction, only the x minus 5's will cancel out, so I'll have b times x minus 3, and we'll end up with this. Okay, so we just cleared the denominators, and then we're going to distribute. And the reason we're trying to distribute is because what we're going to do is we're going to like relate the coefficients. Like we know that over here 5 times x, like if I have all the x's here, let's just work this out. So I want to get all the x's together. Okay, so that I just did that so I can get all the x's together. And then I moved the bx over close to the ax. I just rearranged them. I've still got my other numbers here. And I want to factor this x out because I'm kind of like correlating my coefficients of x. Like this left-hand side says something times x. Well, the something that's timesing x is 5. And the something that's timesing or multiplying x over on the right-hand side is a plus b times x. So therefore, I can say 5 is equal with a plus b. So I write a plus b equals 5. And then this is just a constant. And these are actually they're non-x things. We can kind of lump them in with the constants. So I'm correlating the negative 19 and the negative 5a minus 3b, so that's what I wrote over here. And then I have a system of equations. I've got two equations with two unknowns. I can do substitution or elimination. I usually do elimination. I realize now I could have just multiplied this whole thing by 3 and then just added them together, and it would have been so nice. But instead I used substitution. I did make a mistake. So I subtracted b from both sides here to get a by itself, and then I plugged a in, right? And then I distributed. And then when I combined like terms, I originally messed up and said 5 minus 3 was 3, but it's 2. So anyway, add 25 to both sides. I get 2b equals 6, so b equals 3. So I know that the b equals 3. And then if I plug in, I had a is 5 minus b, so 5 minus 3, that's 2. So, and I don't know if I can, let me go out a little bit. There. So you can see that I solved to find out what number A was and what number B was. That's called partial fraction decomposition.